Hello, welcome to this series of short videos around plant design collaboration. My name is Alexandre Mianache and I work in Paris, France at Autodesk as a technical sales specialist for the AEC sector. We can see we live in a more and more urbanized world where building and facilities owners realize the benefits of BIM, and we of course work more and more with geographically dispersed teams. So this results in huge data explosion, which is even harder to manage, not only in terms of size of data, but also in terms of uh, format diversity, for example. To address these challenges, we've seen a shift in the industry when it comes to project execution. Naturally, this shift isn't an easy task, especially when working across disparate teams based in different locations and delivering on different scopes of work. Coordinating project milestones, juggling data handover, and contract requirements lead to additional customer challenges. And as projects become more complex, this data is being rapidly iterated at a high frequency across teams. Bad information and data silos across companies lead to massive waste that is prevalent in delivering projects, and distributing teams are hurt by delays in communications and waste time searching for the right project information. Every single time a handover occurs between teams or across phases, a data loss occurs, leading to inefficiency and risk. In addition, AC project requirements are changing, and technology to gain even more project clarity is rapidly improving. There has been a fundamental shift in project execution. Today, you see more detailed design engineering upfront, multidisciplinary collaboration. Owner requirements are changing also, as mentioned earlier. As a result, traditional drawing-based methods are no longer adequate. Collaboration is still a challenge today. Taking a look at this picture where engineering firms and general contractors have a lot of workflows and a lot of tasks or documents to manage, like handover to O&M, reporting and insights, BIM collaboration, inspections and checklists on site, document management, managing the mails and the forms. And all this is quite hard to put all together in a consistent way to bring up a consistent final product. So these are the solutions we are going to tackle with our AEC solutions today. We'll focus on security and accountability, on team communication, and on simplifying with easy to access tools the project complexity management. Let's start by discussing desktop-based collaboration. Desktop-based collaboration is covered mainly by the AEC collection, which is part of our plant design solutions. So we will use AEC collections and BIM 360 to collaborate around our plant projects. We covered four main macro tasks that plant project teams need to perform here, which are conceiving, modeling, optimizing the models and the projects, and coordinate them. Let's discuss all these macro tasks. In terms of design, basic design, we can use the process and instrumentation diagrams, the P&IDs, which are, by the way, spec driven in Plant 3D to generate intelligent drawings. We can also efficiently perform preliminary plant layouts using our tools, and co-author and share data using eventually our cloud solutions. This would be covered by AutoCAD Plan 3D, InfraWorks, and Autodesk Recap, which is which manages laser scans and photos. For the model phase, we will use these P&IDs to confirm the process engineering and then build accurate 3D model data. Piping, but also structure, for example, steel structure. We can also use the point clouds to capture existing conditions. This modeling phase would be covered by AutoCAD Plan 3D, Civil 3D, should we have civil engineering to manage, Recap for point clouds, Revit, so this is more building oriented, AutoCAD Electrical, and Autodesk Advanced Steel. For the optimization phase, we will use these models to perform pipe stress, flow stress, for example, leverage BIM tools for architectural and structural design, and also take advantage of the PCF export and import for interoperability with other piping analysis applications. For this task, we will use Plan 3D, Navisworks, Revit, and Advanced Steel for steel fabrication. The coordination phase will connect multidisciplinary teams. They can be also owners or other stakeholders like subcontractors. We can then check clashes, investigate problems, and use point clouds to validate the as-built conditions. We can cover that using Plan 3D, Autodesk Navisworks, Recap, Revit, and of course Advanced Steel. Here's a short example of a simple workflow based on plant design tools included in the AC collection. First, we can take a look at the P&IDs, the process and instrumentation diagrams, and then based on that, based on those process drawings, we will focus on piping equipment, steel structure, which is covered by Plan 3D, some building elements covered by Revit, coordination with Navisworks, for example, and then we will also discuss the deliverables, which in Plan 3D are the bill of materials, the isometric drawings, and the autos used for layout drawings. The Plan 3D environment is easy to access and allows fast project creation and management, as you see here. We have a very easy to access wizard to create new projects. The database is set up automatically. It's either SQLite or SQL Server. We'll discuss that in the third video. Customization is quite simple since it's needed by most of the users. This will be very important to us, and there's no real programming to do it. It's quite simple and accessible. Project templates for project replication. So this is also part of the ease of project creation. And we are on the AutoCAD platform, so we can import, export DWG files very easily. If we had to look at the P&ID drawings a bit further, again, the two master words here, master ideas are easy and fast drawings, using standard symbols that can be easily customized, of course. We can model the diagrams, the drawings using specs and respecting specific specs that were set up by CAD admins. The lines and the components are of course intelligent, so they are dynamic. The symbol management is quite easy to access with graphic interfaces, graphic UIs. And we can also import P&IDs, existing P&IDs. Not only digital, but also sometimes scanned ones. The data management is the base layer of our solutions. This would be the database. which is organized in a project tree. The project tree is just a Windows folder, easy to move, easy to manage, with folders, subfolders, and all the files. The database is as usually in the project um, um, in this project folder. Deliverables, drawings, quantities, bill of materials. Intelligent link drawings. That's another thing to uh, to discuss because that's quite important. All the P&IDs can be intelligently and dynamically linked together from a line to another. You can revise data using the data manager of Plant 3D, and the tags are also dynamic. So when you tag a line components, they're dynamic. They are changing when the line changes. The first point of access of editing or informing people about the project would be Microsoft Excel, which is quite easy to use and well known. So we can export spreadsheets and import them back. The system will recognize changes in this case. And we also have consistency checks between P&ID and 3D data, 3D piping. So it will enable us to make the project consistent. Let's take a look at a short video around P&ID. As you can see, this is the P&ID interface. The project manager on the left manages the whole project. Now we are using a spec-based tool palette to model equipment and lines. We can modify them, assign tags based on specs that were set by our CAD admin. We just need to name the spec, name the diameter, and the tags are automatic and dynamic. The valves and other inline instruments are other inline elements are completely dynamic. As you can see, if we change the diameter, the tags are also updated automatically. So this is another line we are creating here, inserting one or two gate valves, which are again dynamic. And we can also use instrumentation valves to control our lines. So this is the instrumentation part. We can easily control our valve status and use AutoCAD's classic copy-paste feature to copy-paste P&ID elements. This would be the data manager. We can use spreadsheets to export the data. An engineer can, for example, dimension a pump or change a valve status, and then we can re-import that back from Excel. The data manager highlights all the changed elements and we can either accept or refuse all the changes. Equipment or valve reports are really easy to set up as well within the data manager in the solution. Let's now talk about the Plant 3D aspect, the 3D aspect of Plant 3D, I would say, which is all about piping, equipment, and basic steel structure. The pipe routing here is spec-based, just like P&ID can be. The equipment is parametric. We can draw basic steel structure like columns, beams, stairs. We can also import and export Microsoft Excel spreadsheets, as you saw it for the P&ID. And then the deliverables would be isometric drawings, layouts. We call them auto drawings, layout drawings. And we can also fully customize in a very easy way the catalogs and the specs. And as mentioned earlier, the 3D aspect of Plant 3D is also integrated with P&ID with sanity checks and reuse of P&ID data automatically, for example. Let's take a look at a 3D piping video. So we will reuse the P&ID elements. You can see them in the list here to draw, to model the 3D piping on this 3D drawing. So we just use two P&ID lines. Then we will add the inline elements, the butterfly valves we had on the P&ID. As you can see, the elements are fully intelligent. We can change the levers, for example, if needed. This comes from a specific library that can be also customized. You can also change some of the geometry in this drawing. We can add support that adapt automatically to the nominal diameter, for example, and to the line tag. They can be easily modified. This solution can be used with metric units, but also imperial units. Let's take a look at the equipment aspect of the 3D, Plant 3D. We have a quite nice and complete library of elements of equipment. But should you need to customize that, you could also use import elements from equipment design software such as Autodesk Inventor. This is what we do here, and the export will keep the main setups like the entry points, etc. Let's take a look at deliverables. Again, based on our 3D modeling, we can easily generate isometric drawings, but also layouts, piping layout drawings. We call them auto drawings. That's what you see now. You can add bill of materials from these elements on the drawings, which is very important. So isometric and orthographic drawings with full bill of materials, dynamic bill of materials. So should you need to build a full project report in terms of deliverable, that's also important. We can easily query the plant database to build more completely reports around more elements than we can do in the plant project with data manager. Here we will use the report creator. This is an external tool for which no license is required, so anybody can basically acquire the project without being a plant user and without needing a license access. So this is a powerful report tool that can be scripted, customized. It contains filters working for drawing or projects, and we can easily export a consistent project report to Microsoft Word, Excel, and or PDF format. Let's take a look at Revit. Revit will help with building elements here. Just as a reminder, Revit file is just one full database containing everything. In fact, it contains parametric families, all the objects, views, and all the elements you can have in a Revit file are called parametric families. This solution addresses three main groups, which are architecture, structure, and mechanical engineering and plumbing, MEP. You have a very quick, short example of the different extensions of Revit files on this image. In a Plant 3D project environment, Revit will help with building elements, mainly cable trays and ducts, but also concrete design for formwork or rebar, should you need to design these elements. We also have advanced steel for steel detailing and fabrication. This will of course, it's another AutoCAD-based application that communicates quite well with Revit, Plan 3D, robot structural detailing. The idea here is to use dynamic modeling, um, use a very dedicated tool palette with pre-created elements that you can all just change. You can just easily change the geometry and the forms. We have a bunch of steel connections. There is also a clash check functionality. You can use them for customer presentations, of course, but one of the most interesting aspects is also the BIM workflows, the connection, just like mentioned, for to Revit Robot, Navisworks Plan 3D, which is of course native. Based on that, we can easily generate fabrication drawings for steel members and connections, but also perform automatic CNC data creation. You can work in a multi-user or single-user mode. Should you need to perform multi-material analysis or code check on your structures, being steel structures, concrete structures, even timber structures, robot structural analysis helps with that. You can also perform dynamic analysis, for example, seismic analysis on your structures to see if they fit. Also, for example, supports can be steel member supports can be dimensioned and cut checked with this solution. Robot is integrated with Revit, Advanced Steel, and also Plan 3D. For coordination purpose, we can use Navisworks. Navisworks is a great 3D model aggregator. We can aggregate models, but not only models, also the properties of these models, and bring together multiple format files. We can then review models and coordinate them with thanks to 6 specific modules, like Clash Detective, which checks, of course, clashes. This is the one that Navisworks is the most famous. Um, Timeliner, Animator, Scripter, and Presenter. Those are the 6 specific modules that help, for example, connect the construction to a construction planning. We can also easily generate animations and script all that to make realistic visualization presentations. Another aspect of Navisworks would be the management of quantities and costs in a construction environment. Let's take a quick look at the coordination video. This is a complete pump station 3D model combining Plan 3D, Revit. This is Revit. This is Navisworks. This is where we combined all the models together, aggregated all of them, and checked clashes. For example, steel beams and pipes. We can then assign a clash in a really easy way, and people will be notified. They will change their design model, and we can bring that back to Navisworks. Should we need to address master planning and building components, we can use InfraWorks, which is another great solution, including in the AC collection. Can study master planning, surroundings, bring that into Revit and Plan 3D, build the elements. They use P&ID to understand the process when designing or pre-designing the facilities. All this is linked to the database and everything is linked together, P&ID and Plan 3D as stated before. And all this is included in Revit, for example, to combine structure models and piping models. You can then use connections and bring them back to Navisworks, where we can detect and assign the clashes. We can then generate nice visualizations when we can combine everything into InfraWorks to understand the inside of a plant, but also the surroundings. Next step would be to discuss the laser scans and photos, which are addressed by Recap Pro. You can capture the environment, perform as-built comparison, also have accurate measurements. Also, as you can see it in this video, we can mix laser scans and photos with 3D BIM models for comparison purpose or just understanding the layout or understanding the danger zones, safety zones. We can also perform reverse engineering thanks to those solutions and quality control verification. As you can see in this video, the different elements from the 3D model are identified and we can see them in context using the not modeled but scanned rest of the plant and the surroundings of those 3D model elements. Let's now quickly take a look at the database structure. Basically, here I described what's inside the plant project in terms of database. So earlier in this video, I told you that a plant project is just contained in a Windows folder. This is the case. The plant project is just a Windows folder containing subfolders and the databases. The project databases, the specs, specifications databases, and also the DWG drawings. Usually the project is local in a Windows folder or managed by Vault, which will be covered by a third video we will have for this series. The catalogs usually, those are like ASME catalogs. The catalogs are usually feeding the specifications. They are external to the project, usually stored on a network drive or locally on your machine or in Vault, depending on the project needs. Let's take a look at a quick video around catalogs and spec management. We can easily access the spec management from within Plant 3D by using the project manager I described earlier. Let's take a look at the Carbon Steel 300 spec, which is a quite classic one, an ASME one. When I hit edit spec here, then an external program will open the specification. This program is called Spec Editor. This is a CAD admin, BIM admin program, which allows to create and update the specs based on the catalogs. This program doesn't require a license, so you don't need to be neither a user or to have a license of Plant 3D to use it and to create and manage the specs and the catalogs. Catalogs can be loaded freely from our Autodesk App Store. We have a quite large number of free catalogs created by Autodesk, so such as UK Ductile, American Content Pack, Pharma Pack, EPEX, etc. So the upper section of the spec editor shows the specification, what is contained in the spec. We can also see the the priority. For example, for an elbow of 6 inches, will we will it be preferable to use a 90 degrees elbow or 45 degrees elbow? The bottom part shows the catalogs. We can access them and filter them in an easy way. You can filter on the fittings, for example, with a specific end connection, and then just pick the element and add it to the spec. You will see it in the top list. We just hit add to spec here, and we will add a new elbow, 45 degrees. We will then save the specification so it can be used by in Plant 3D. It's quite easy to export and to import to and from Excel. The branch table editor is quite important too. This is where you decide, where the CAD admin decides how to connect, for example, 8 inches to 12 inches pipes with a specific priority between T's and reducer, stub-ins, socolet T's, etc. The catalogs can also either be built or modified or managed here. Let's pick a pipes, ASME pipes and fitting catalogs and just look at an element. This is just a regular elbow. You can see that we have all the geometric and all the other info and properties. We can very easily create new components based on either AutoCAD blocks or design programs such as Inventor, for example. We mentioned that earlier. This part of the video, I just wanted to show you the how large the library, the existing one is. You can either customize those elements or just create them from scratch using AutoCAD blocks, for example. We also can convert external tools, contents like CADWorks or AutoPlant, or anything that would export Excel spreadsheets. The new element we added to the spec from the catalog is now available in Plant 3D, and we can easily use it for our design. We can also take a quick look at the spec in Plant 3D. We can see it as a list in a very easy and accessible way. This is our new elbow we just added to the specification from the catalog. We also have another solution called Raster Design, which is just included in the one AutoCAD package included in the AEC collections, where you can reuse, and analyze existing drawings. We can specifically use that for scan drawings on plants, including P&IDs. We could also manage satellite images or aerial pictures in a very easy and friendly to use way. We mentioned earlier the pipe stress workflow. We can actually export, so after modeling the 3D piping and maybe generating isometric stress drawings, we can easily export in a PCF format our 3D piping to a stress analysis program. We can then calculate and analyze the supports and bring them back to our 3D piping solution. So PCF exports to programs to perform stress analysis, and this would be the recommended workflow with our solutions.